Hey guys, this is Carrie, and this is the answer key for homework number 9. This one's going to be all review. So express 1 minus I cubed in a plus bi form. This is Unit 5, complex numbers, if you needed a refresher. But I think you'll be good based on the work that we did in class today. So we've got 1 minus I cubed, which is 1 minus I times 1 minus I times 1 minus I. Now, it can be a little bit overwhelming to try to multiply 3 things, but if you think about how you might do a multiplication problem with 3 things, say with numbers 2 times 5 times 3, the way many people will do this is 2 times 5 is 10, then times the next number, which would be 3, that would give you 30. And we're going to approach this one in the exact same way. So the same way that we started here where we multiply the first 2, we're going to be multiplying the first 2 and then following up by multiplying this last one. So distributing here gives us 1 minus I plus I squared. Now we have all of that times the original 1 minus I that we had before. You can keep distributing from here, but I think it's going to make our life easier if we combine some like terms. So here we have 1. This is going to be minus I is negative 2I. And then I squared, this is an important identity. I squared is negative 1. So when we add negative 1, it becomes minus 1. And we have all that still times 1 minus I. Now here we're lucky. 1 and negative 1 cancel out, and we get negative 2I times 1 minus I. Now we distribute another time, giving us negative 2I plus 2. I squared. Now we use that same property. I squared is negative 1. And so that becomes negative 2I plus 2 times negative 1, which is negative 2I minus 2. Now technically for a plus bi form, we should have our real part followed by our imaginary part. So this is the final answer. Solve the following equation for all values of x. So with these problems, we want to get a common denominator. So approaching this one, we get 1 over x plus 3. That looks good. Minus, and I'm going to leave this one off because there's something funky going on with this denominator that I think if we look at the last fraction will help us to see how to handle this yellow fraction. All right, so coming back to that one, on the right side, we have 8 over, and we're going to factor our denominator here to make it easier to see how to get a common denominator. So we get x minus 3 times x plus 3. Now, one of the factoring patterns that we saw this year is going to help us a lot. If you look at this pink group here, 3 minus x, and then this factor here, x minus 3, you can see that the major difference between them is that they just have opposite signs. Here x is negative, here x is positive, here 3 is positive, here 3 is negative. So you can actually easily transform this pink factor into this factor. And the way that we're going to do that is to flip the signs. You multiply by negative 1 to the numerator and denominator. That will give us negative 1 on top, and on bottom when you distribute this minus 1, you get negative x, which is x, and negative 3. And now that these match, our life is much better. However, we haven't managed to completely match things. We still need to get common denominators. So this x plus 3 denominator is missing the x minus 3 that this one has. So you have to multiply by x minus 3 to numerator and denominator. This one, we notice that minusing a minus will make it positive. And then for the denominator here, we're missing the x plus 3. So we'll multiply by x plus 3 in numerator and denominator. Now, if we do this, all of our denominators will match. And one thing that we saw is because we're going to be eliminating the denominator, we can distribute in the numerator. That will give us x minus 3 plus 1x plus 3. I guess these are all separate fractions still. This denominator we want to distribute x minus 3 times x plus 3, x minus 3 times x plus 3, equals 8 over the same denominator. And one of the things that we talked about in the last video is because we realized that our step is going to be to add these fractions and then multiply by the denominator. When we multiply by x minus 3 times x plus 3 on both sides, all of the denominators are going to cancel out. And that leaves us with a much easier equation, which is x minus 3 plus x plus 3. That gives us 2x. Minus 3 and plus 3 cancel out. Equals 8. And now we're one step away from solving for x. We divide by 2 on both sides, and we get x equals 4. Now, it's tempting to think you're done there, but we're not. The reason why we're not done is because these are fractions, we should have done a pre-check in order to discern what the values of x that are not allowed are. Because there's something that can go wrong with fractions. With fractions, you cannot divide by 0. So to avoid dividing by 0, it looks like we'll have to make sure that, I'm just going to erase some of the clutter here. It looks like we'll have to make sure that x is not negative 3. And for this one, x is not 3. And if you look at the next one, the factors here would imply that the same solutions would cause issues. So comparing what x cannot be from the pre-check with what x is, we can validate our solution because it's not one of the excluded values. Which of the following solutions are solutions to the equation below? So in class we were talking about factoring things that look like this. And you could try to factor it, but a giveaway is if you look at the answer choices, these aren't going to come from factors, these solutions. So this probably is actually a quadratic formula problem. So since factoring will likely fail based on what those look like, we get x equals, and then the quadratic formula is given to you on the regions, but perhaps you haven't memorized still, b squared minus 4ac all over 2a. This one's glued in my mind from high school. And we get x is equal to, now substituting into the problem, we have a, b, and c, which refer only to the values, not to the variable part. So we get negative 2 plus or minus the square root of 2 squared is 4, minus 4 times 3 times 7 all over 2 times 3 is 6. Now x is equal to negative 2 plus or minus the square root of 4 times 3 is 12. 12 times 7 is, wow, this is looking pretty bad here. Let's see. 12 times 7 is 4 and 1, that's 84. So you get 4 minus 84 all over 6. So and x is equal to negative 2 plus or minus the square root of negative 80 over 6. And that doesn't match any of our answer choices. And I think that's why I paused for a second. But there's a couple things to remember here, which is we can actually simplify the square root in a couple of different ways. So one way that we can simplify it is we recognize right away that the square root of a negative number will be giving us an imaginary number. Another way that we can simplify it is the square root of 80 can actually be broken down. So if we break the square root of 80 down into its prime factors, we get 5 times, well, I won't do that one because I don't think a lot of people will see that one right away. We'll do 8 times 10, 4 times 2, 2 times 2, and then 5 times 2. So our prime factors are 2, 2, 2, 5, and 2. So our solution will become x is equal to negative 2 plus or minus I times the square root of 2 times 2 times 2 times 2 times 5. Now these groups of 2, when you square root them, one of them will be left and one of them will disappear, and that will all still be over. Why did I write 60 there? That should have been 6, right? I hope you caught that. And this is a little bit sloppy, but x is equal to negative 2 plus or minus 2 of the 2's come out, and then we're left with this. Now the final thing to realize is all of the values outside of the square root can all be reduced by the same number. What number reduces 2, 4, and 6? Yeah, that number is 2, so we reduce by 2 in the numerator and denominator, and that leaves us with our final answer. X equals negative 1 plus or minus 2i root 5 all over 3. Which is this answer. Okay, so now this one is actually a Unit 4 problem. So Unit 4 was all about the graphs of parabolas. And probably the most challenging topic, which is also one of the ones that appears most on the Regents, was these questions had to do with focus and directrix. So let's see. A good idea when you encounter a problem that involves things to graph is to actually graph it. So we'll graph it. It doesn't have to be very neat, but we'll put the key values here. So y equals 1. That's a line going through the y-axis at 1. Then we've got our green focus, which is at negative 1, 2, 3, 4. 1, 2, 3, 4, 5. And maybe I'll mark the 1 as well. So we have our focus, let me label it, and our directrix, let me label it. So the way these problems work is the parabola actually passes halfway in between the focus and the directrix. So the vertex of the parabola is going to be halfway in between these two lines, and then the parabola curls upwards to go, whoop, that didn't quite work, curls upwards to go around the focus. So now all we have to do is find the equation of the parabola that we just drew. So we talked about this recently in class. The basic structure for a parabola is y equals x squared. But we're going to have some inside and outside transformations to move the vertex from the origin all the way up to the point that we just found, which I'll label V for vertex. So it looks like we're going to have to go back 4, which should be an inside transformation of plus 4 because it's the opposite of what you expect. Now to make this a parabola, this should all be inside of the squaring function. Now to move this up, we need to figure out, well, how high are we moving it? Because we just drew a rough sketch. But because the vertex is exactly in the middle of these two, focus and directrix, we know that these are equidistant. So the distance from 1 to 5, that's 4 units total, which means each of these will have to be 2 and 2. So it looks like 2 units above 1. It looks like this will be back 4, up 3. So I'll have an outside transformation of up 3 to move it up 3. Now the last part about this is to find the coefficient that goes in front of the x squared term. And so to find that value, we had a formula, which is a is equal to 1 over 2 times the total distance. So the total distance was 4, which gives us 1 over 8. Now there's a last consideration looking at the answer choices is, should this be negative or positive? And to make the decision, since the parabola is concave up, it should be positive. So this is our final solution. Now I think it'll be good for you to practice this on your own with the next problem. So I'm going to leave this one unanswered, and you can get some practice working on it and check with maybe your peers when you come in tomorrow. Now the final problem here is actually a Unit 7 problem, which was our polynomials unit, and that had to do with polynomial division, and this is a little bit of a warm-up for that. But you could actually just think about it as a distribution problem. So we have this crazy expression over here is equal to this crazy expression over here, which means when we distribute all this out, we should be getting this. Now that we've got a game plan, let's see how it helps us to solve it. So there's nothing to simplify on this side, so we'll check it off. Well, not really. But on this side, we'll distribute. We do x times 2x squared, which is 2x cubed. And that's great news because we wanted a 2x cubed. Now what we've seen is with problems like this, rather than distributing this x to all of them, it's helpful to alternate between x and negative 4. This gives us negative 8x squared, which is less successful than the 2x cubed because we actually want negative 10x squared. So it must be that the next thing we distribute is compensating or filling in the part of the negative 10x squared that we don't have yet. So x times what would combine to give us negative 10x squared? Well, it looks like h has to be negative 2. So when we do x times negative 2x, it gives us negative 2x squared, which does combine to give us negative 10x. But when we place this negative 2x there, we also have to do negative 4 times negative 2x, which is positive 8x. Now we do x times 3, which is positive 3x, and that's good news because together these make 11x. Now we do negative 4 times 3, which is negative 12, and that's not so good because we actually want negative 7. But we're lucky because we have this remainder term, which is the right word for it, you'll see as we review some more topics in here, to compensate. So what else do we need to add to this? Well, we need to add 5 in order to complete this. And that would give us the negative 7 that we were hoping for. So we've managed to match everything up as long as h equals negative 2 and k equals 5. So if you needed more practice looking at problems like this, Unit 7 would definitely be a good place to look. I hope you guys found this to be a helpful review for your Regents, and make sure you're studying. We only have 3 weeks left. See you guys tomorrow.